In last class, I have discussed about the work done. I am extending this topic. Work done is equal to force time displacement. Now I am taking an example just like a man carrying a bag on his head and moving with a speed v, or we can say it displaces in this direction. But here the force is acting on the man by this object is in this direction due to gravity. So here force direction is this and displacement direction is this. These are perpendicular to each other and the work done is 0. From the physics definition we can say that when a man carry a bag on his head and moving forward, he did 0 work done. Okay. Now I want to tell the conservative force definition. Conservative forces are those for which del cross F is 0. F is force here. Means this force is irrotational. If this force is irrotational, then we can say it is a conservative force here. And we can define a force in terms of potential. This is the potential. We will discuss it later on, electric potential and gravitational potential and all. We can only define this potential if this force is conservative. Okay. The example of conservative force is gravitational force, electrostatic force, and non-conservative forces example are frictional force and all, and some other forces are there, I don't know. Let us now discuss about the collision in the physics. Collision means two bodies are collide with each other, then what will happen? Collision is two types: elastic collision and non-elastic collision. I am discussing these two topics. Elastic collision. What is elastic collision? In which two bodies collide with each other and then momentum conserved and kinetic also conserved in elastic collision. But in non-elastic, momentum is conserved but kinetic energy is not conserved. So we can say that some kinetic energy is lost in this collision. Non-elastic, or we can say here inelastic collision. Okay. Then one of named term is coefficient of restitution. What is that? Coefficient of restitution is that velocity after relative velocity after collision, relative velocity before collision. Means let us say we have two bodies m1 and m2 mass moving with u1 and u2 in same direction, then they collide and their velocities are different. Then m1 is the mass same, v1 is the velocity of m1 and v2 is the velocity of v2 after the collision. Then coefficient of restitution is v2 minus v1 upon u2 minus u1. So the coefficient of restitution is v2 minus v1 upon u2 minus u1. I'm gonna tell you one thing, that in elastic collision if it is perfectly inelastic, then after the collisions both the body moves with same velocity v. That means v2 is equal to v1 equal to v. Then the coefficient of restitution will be 0 for perfectly inelastic collision. And for perfectly elastic collision, E is 1 because v2 minus v1 equal to u2 minus u1 for perfectly elastic collision. Okay, now I'm taking an example. One body have mass m1, speed u1. Second body is mass m2, speed u2. After the collision, speed is v1 and speed is v2. So let us consider the example of elastic collision in one dimension. Elastic collision in one dimension. Okay, then apply the momentum conservation here. m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Also kinetic energy also conserved here because elastic collision. Then kinetic energy conservation v1 square plus half m2 v2 square here. This is the kinetic energy conservation equation and this is the momentum conservation equation. Both the equation will be helpful to determine v1, v2 and all. Okay, let us consider two-dimensional case. Both the bodies here m1, m2 and speed are u1, u2. After the collision, let's say m1 goes just like that with speed v1, m2 goes here just like that, and this is making angle theta 1 and theta 2 with the direction of incident collision particles. So this is also elastic. We are considering here elastic. Then momentum conservation in, let's say this is x-axis and this is y-axis. Momentum conservation in x-axis is m1 u1 plus m2 u2 equal to, what is the x component of this particle? m1 v1 cos of theta 1 and x component into v2 cos of theta 2. There are two equations governing the momentum conservation here, x component conservation and y component conservation. There is no y component in this side, so total y component will be 0. So its y component m1 v1 sin theta 1 will be equal to m2 v2 sin theta 2. And there is no direction of conservation of kinetic energy. Then kinetic energy equation conservation is same as just like that. In one dimension we did m2 v2 square. So the only thing we understand here that momentum conservation will be directional, and energy conservation we will only see right hand side and left hand side energy, total energy. And we know that total energy is conserved for a isolated system always. Okay, next I'm gonna tell you about the friction and frictional forces and all. What is friction? Friction is friction is what? friction tells us that about the, let's say we have two surfaces. Then what is the friction? Friction is the interaction between their atoms and molecules. Okay, how much they interacting with each other, that determines the frictional forces. And let's say we have a sand and smooth surface. Friction is more in what case? Tell me. Friction is more in sand case, because sand in sand our feet are going downward in this, and the more atoms are interacting in sand, then the friction is more in sand than the smooth surface. Okay, so I'm going to tell you the friction will depend on the material, because in sand friction is more than the surface. The only dependent of friction is material. Then I'm going to tell you friction is of two types: external friction and internal friction. Internal friction I'm not gonna going in details, because it is a friction between two layers of a liquid. It is not the part of physics here now for net ZRF and all. And I'm gonna tell you the friction for external friction. External friction is what? Between two bodies, between two atoms and all. Okay, external friction is of three types. First one is static friction, limiting friction, and kinetic friction. What is static friction? Static friction in which the actual body motion is in rest, but it tends to move, but it is actually in rest. And kinetic friction is that in which the body just starts to move. And the limiting friction is maximum friction for which the body stops to move. Okay, in this tends to move, in this just starts, and in this just stops. Okay, and then we can see here the kinetic friction I am defining is K, limiting friction is L, then K is less than L, of course. Okay, next definition is force of friction is what? Force of friction is mu times reaction force. Reaction R is normal reaction. Here mu is what? Coefficient of friction. It is different for static, limiting and kinetic, and here definition will change, which F is less than equal to mu R. So here mu depends on, of course, the nature of material and surface, nature of material, and about the nature of surface also. कि that surface is dry, wet, rough or smooth. Because for dry and wet, for wet friction is less and dry for friction is more. For rough friction is less, for smooth friction is more. Because the atom interaction between smooth surfaces and the rough surfaces will be more than in smooth surfaces, and in rough surfaces interaction is very less, and we can say the friction is more in smooth surfaces than the rough surfaces. Okay, now I am going to discuss that. Let's say we have a car. Okay, it is moving in this direction with speed v, and we started applying brakes here, and it stops at this point. Let's say this is the distance d here. Then what is that distance? I'm gonna tell you that. Let's say its mass is m. Starting, its kinetic energy is half m v square, and the final, let's say it is initial, let's kinetic final is equal to 0. Then by the work energy theorem, kinetic energy final minus kinetic energy initial, what is that minus sign represent here? Minus sign represent has the frictional force is acting in opposite direction to the motion of the car, and this work done will equal to force of friction multiplied by the distance covered when the friction applied here. Force of friction is mu times normal reaction. What is normal reaction here? This is the car, and this is the gravitational force acting in this mg, and the normal friction is this. Normal friction is mg, and the force of friction is mu times mg. So here the d will be, let's say, the magnitude half m v square divided by mu times mg, and v square by 2 mu g is the distance covered when we apply the brakes there. Okay, and of course this distance will depend on the force of friction here and the speed also. Okay, now let us take the example of inclined plane friction. In inclined plane, let's say this is the angle alpha, and this is the body whose mass is m, let's say, and this is the gravitational force acting in, and the angle it makes with perpendicular direction is alpha, and in this direction its component of force of gravitational force component is mg cos of alpha, and its perpendicular direction mg sine of alpha. Then I am defining a quantity angle of repose or sliding. What is its definition? This is the angle alpha, the minimum angle of inclination of plane with the horizontal such that the body placed on plane just begins to slide. Okay, this is the definition. The minimum angle alpha we required minimum angle alpha so that it slides on this plane. And what is that angle? We have to find that. For this, it is sliding in this direction, then the force of friction is acting in this direction, and the normal reaction is what? Mu time, sorry, normal reaction is mg cos of alpha. Okay, then force of friction is mu times mg cos of alpha. Okay, for minimum angle it just starts to slide. Let's say it stops, let's say it is at same place, it is not sliding here, then we just increase our alpha, then it just starts to slide. At that point frictional force will be equal to mg sine of alpha. Okay, then tan alpha will be mu, or we can say the alpha is very less than alpha immediately equal to mu. That is, angle of repose or sliding will depend on coefficient of friction. Okay, for alpha greater than mu, it slides down, and slides down it gains some acceleration. And what is that acceleration? That force will be mg sine alpha minus force of friction, and I'm just calculating it. G sine alpha, it is force of friction, mu mg cos of alpha, m cancel down, and that was mu cos of alpha. That was the acceleration when it starts to slide down. Okay, next, if you want to do any problem in this, you can do easily by force balancing equations and just simple calculations here. You will find that. Next, I'm going to discuss about the gravity. What is gravity? Gravity is the gravitational force acting on any object on the earth or any other planet, or on any body, we can say, which have some mass and some size. It have gravitational force acting on it. Let's say our earth example, and the gravitational acceleration, I'm defining it gm by r square. Here m is the mass of the planet, and g is the gravitational constant, you know that, and r is the size, radius of that planet. Okay, so it, from this formula we are understanding that gravity is not constant for all the planets or for all the bodies, because the mass and radius will vary. Because the moon mass and radius will be small, then the gravity will be small, and then we can say other planets also there. If we have given the mass is 3 times mass of earth and radius is 2 times radius of earth, then the gravity of that planet will be 3 upon 4 times gravity on earth. Okay, now I'm going to discuss the variation of g, how g will vary with the altitude, depth, or any other parameters. First I'm going to tell you altitude effect. When we go upward from the surface of earth, let's say this is the surface of earth, when we go upward, then the g will decrease or increase. We will see it. Let's say it is our earth whose radius is r. Let's say this is the surface and it goes to some height h. Let's say this point is b and this point is a. We know that Ga equal to Gm upon me r square. The mass is the mass of planet and r we have represented here. Then gravity at b, what will be? Mass will be same for at that point also, Gm, and the distance between center to this point will be r plus h whole square. Okay, I'm gonna some calculation in this. Let's say r common here, r square, then this is 1 plus h upon r whole square. Since this h is very less than r, so I'm gonna reversing it, 1 plus h upon r whole minus 2, sorry, and gb will be, I'm gonna expand binarily to only one place, Gm upon r square 1 minus 2h upon r, and Gm upon r square is gravity at point A, Ga 1 minus 2h upon r. From this we can say as h is increases, gravity will be decrease. Okay, next point is depth effect. If we go below the surface of earth, how the gravity will change? Let's say we goes to this point. Let's say this is point A, this is point B, and this is, let's say this is the spherical path, or this is small sphere we are considering here. Let's say we have earth has uniform mass density rho, and the rho is m upon me 4 by 3 pi r cube. Okay, this is the uniform mass distribution on the earth is, let's say we have uniform, let's say this distance is d, let's say from the surface we goes to depth d, then this will be r minus d. Okay, then the gravity at point P will be G mass at point B divided by r minus d whole square. First we have to calculate the mass comes in this pair. What is that mass? We have to calculate that. Mass will be 4 by 3 pi r minus d cube rho. Okay, let's say that we have GB by GA, GMB r minus d whole square. What is GA? GA will be GM upon my r square. Okay, so here MB, what is MB? MB is written there, and what is M? M is 4 by 3 pi r cube rho. G will cancel down, and MB 4 by 3 pi r minus d cube rho multiplied by r square divided by r minus t whole square, and mass, what is mass? 4 by 3 pi r cube. Rho will cancel down, r cube will cancel down with r square remaining r. Similarly here, so gb by ga, what will be? R minus t divided by r, that was 1 minus d by r. It means gb equal to ga times 1 minus d by r. It means if d is increases, means depth is increases in the earth or in any planet, gravity will be decreases. Okay, means we are going downward. Let's say this is surface, this is the center. As we reach to center of the earth, d will be r, that d will be r, and the g at center c will be ga times 1 minus r by r, that will be 0. It means from the surface to center it is decreasing, and from the surface to altitude it is also decreasing, and that surface it is constant. Standard value will be 9.8 meter per second square. Okay, third factor is shape of earth. As we know that shape of earth's shape is not properly spherical. R will vary. R on equator, the equator and poles. R on equator is greater than R on poles. So we can say gravity on equator will be less than gravity on the poles. That implies that, let's say this is the equator and this is the poles, north and south. It means gravity at this point is smallest, and we go to this path, we go to the poles direction, it is increases, and it is increasing in this direction also. So I'm going to discuss